This is the main game screen in Game View. And you'll notice that these are the components where here are the buttons that we saw that do motion, left and right, up and down. Here's the fire button. You'll notice that here is the player ship. This little line in front of it that you're looking at there is the laser bolt. You have a small asteroid, a large asteroid, a game over text, and you have the score text. And there's a background. And this background just happens to be the size of the play area and encompasses the entire play area. So if we go to scene mode, you'll see the background area here, which is the game area. You'll see the objects that we talked about. Okay? So let's look at background. All right? Now the background, let's bring it up a little bit. You'll see that its view is pointing down. That's because our camera is, we're using a orthographic view, which essentially says the perspective is the camera is coming down from the top. So everything looks like it's in the same plane, regardless where it is. But if you'll notice, the background is not in the same plane as the game objects. And that's because if the background were in the same plane as the game objects would look very dull and muddy because they're being overshined by the background, which is pretty elaborate. So what we do is that because it's an orthographic view, height does not matter, because when I look at it, it's going to look like it's all the same plane. So we drop the background down minus 10 pixels or units. I'm not sure what the units are, but it's minus 10 in the Y direction. And what that does is that now that removes it from the main plane where the components are. But when you look at it from the game view, as you can see, it appears to be at the same level as everything else. And this allows the game components to pop, all right, or they would be pretty muddy. Okay, now we also talked about in the home screen was the boundary. Okay, so we have the same situation here where this boundary is the, as you can see, the boundary. Let's bring it around. Okay, let's do the boundary. Okay, so as you can see, there's this boundary again. And the boundary is beyond the game area. And this bitmap that you're looking at of the nebula is the game area. And it's the same reason. When a laser bolt leaves the view of the game area, you have to destroy the laser bolt. And when an asteroid leaves the game area, you have to destroy the asteroid, and you also have to subtract 20 points from the score because the asteroid has gone by you. And as we witnessed that with the game. All right, now you'll notice that it has that destroy by boundary script. It's the same script that was in the home screen. As soon as anything crosses the boundary on exit, so as soon as you exit the boundary, it will terminate the object and destroy it and so forth. Okay. Now there's the button scripts and there's the buttons. Now you'll see that there's the down button, fire button, left and right. As you can see, that these buttons here. All right, and they operate pretty much the same as the buttons on the home screen. The only difference is that if we look at the script for the down button pressed, down button pressed. Okay, you'll see it looks pretty much the same. The difference is now we're looking at on mouse down, on mouse up, on touch begin, on touch end. Okay? And the reason for this is that in the home screen, we only essentially had to initiate an event. So we could have chosen on mouse down to initiate the event or mouse up to initiate the event. And then we're going on and do things. In the gameplay mode, it's a little different. When you press the button down or you click the mouse, we have to set up a certain mode. And then when you pick up the mouse or you pick up your finger from touching the screen, we have to change the mode again to the alternate mode. And in order to do that, we need to look at both events. Mouse up, mouse down. But everything else is pretty much the same. And as you can see, when it's mouse down, each one of these calls the move ship vertical function. And if it's left or right, you'll see that it calls the move ship horizontal function. Okay? So that pretty much takes care of the buttons. Now we'll look at the main players. There's a bolt, there's a large asteroid, there's the player, and then there's the small asteroid. Let's look at the bolt. Okay, as you can see, this is the bolt, and let's see if we can get you a different, little better perspective. Okay, there's the bolt. If we look to see what's on the bolt, you'll see that there's a mover script, and you'll see that there's this thing called a capsule collider, and it also has this component called a rigid body. The transform component has to do with its location and where it is, its size, and so forth. All right, so we have to add a rigid body to it because it actually is an entity. And it does have a mass, and the physics will come into play with that. Also notice there's a capsule collider. There are several different colliders in the Unity system. This one happens to be a capsule collider, and as you can see, it looks like a collider. It looks like a capsule, actually. And that's the green lines that are surrounding the. Let's see, that's the green lines that are surrounding the laser bolt. Okay? And you'll notice that it's set for trigger. So that means that if anything crosses the plane of this boundary or this collider area that you see there in the green, it'll launch an event. And that event will determine what to do. Okay? So now we also look at this mover script. So why don't we go and look at the mover script? Mover script. As you can see, the mover script is quite simple. What it does is that it tells the rigid body that it has to be at a velocity of transform of dot forward multiplied by this speed. Okay? And what that does is that activates the physics component in the rigid body of Unity, and the laser will actually go in a forward direction and continue to move until it exits the boundary, and then when it exits the boundary, it's destroyed. Or if it hits an object, it'll be destroyed. All right? And that's pretty much the laser bolt. Let's look at we'll look at the small asteroid. The large asteroid is essentially exactly like the small asteroid. The only difference is the scale. The scale on the large asteroid is twice the size of the small asteroid. But all the components are the same, so we'll look at the small asteroid. All right, so let's bring the small asteroid into view. Okay, so as you can see, here's the small asteroid. And as you can see, it has a texture and material, which is the bitmap that gives it the texture and material of an asteroid. You'll also notice there's the capsule collider again. And this is the green lines that you see. So that's a capsule collider. Now, the asteroid has two scripts associated with it. Not only is it moving, but it also has the destroy by contact script on it as well as the moving script. And then there's also the random rotator script. So when you notice in the game, the asteroids are rotating. And that takes advantage of the rigid body physics component that has to do with angular velocity, angular acceleration, and that's where we deal with that. So let's look at the destroy by contact first script. Okay, so you have your normal startup. This is just a method that I use to create things. It's a wrapper. When it's in multiplayer mode, it uses one type of instantiation. When it's in single player mode, it uses another type of instantiation. This just makes it nice and clean. Same thing with destroying the components. Now, this is the on-trigger enter here. Now, look at the difference between the on-trigger enter and the boundary. The destroy on boundary uses on-trigger exit. That means that when the object is already in the boundary, so once it exits the boundary, this script gets launched, this event gets launched, and the item is destroyed. In the destroy by contact script, you see that we're using on trigger enter. And then it talks about this collider and the other. Now, there's a distinction between collider and collision. The difference is that in a collider, it's the event occurs when you enter the field, the collider field of the item, and the script will launch on the item that you moved into. So that's important because you've got to know who's going to execute the code. So, for instance, in this case, if we look at the laser bolt, okay, so if we look at the laser bolt code, all right, and that was just using the motor, the mover. It wasn't using, it has collider, but it's not executing any of the scripts on the collider. Okay, so it's just using the mover code. All right, and this is because the laser is moving forward and it enters the field, the collider field of the asteroid. So the code executes in the asteroid component, not the laser component. Okay, so that's why there's this distinction. Now, let's get back to destroy by contact. So in a collision mode, what happens is that you bumped into something. So Unity creates a collection of all the game components that bumped into each other. And now you have to determine what to do for each individual game component on that collision. Some might be people that just bump into each other and move away. Another component might be they ran into a wall and they get hurt, or they moved into a bomb. And when they moved into a bomb, you've got to realize that you've got to destroy the other players and so forth. So it's a little different than the collider. So it's an important distinction to know when you look at the scripts. The other thing here is that notice in the on trigger enter, you'll see that there's this check for, is it a boundary or is it an enemy? The important thing here is that in order to locate what these objects are, you have to give them a tag. And I'm trying to locate the tag within the collection, and once I find that tag, I have a handle to the object. And I know which one it is I'm dealing with. So when the asteroid is created, the effect to Unity is the boundary has entered your field. So in the collider, the boundary is the other, which is the thing that entered your field. And your code is going to say, oh, something just entered my field in the collider, so I'm going to explode. And I'm going to explode the other item. So in order to prevent that from happening, we have to check to see when the object gets created, is the other that just penetrated my collider field the boundary, or is it an enemy? And in those cases, I don't want to destroy myself. Okay? Now we go to check to see, is it a small asteroid, large asteroid? And the way this logic reads is, remember that if the small asteroid makes contact with the large asteroid, the small asteroid is destroyed, not the large asteroid. Now, if a player makes contact with any of the asteroids, then both the player and the asteroids are destroyed. And this is essentially what the logic is doing. So down at the bottom, once it senses that a collision has occurred, it will create an explosion, and then it'll destroy the game components. And they both leave the screen. So that's what the contact is doing on with the asteroid. And so here we are with the small asteroid. Okay, so the random rotator, that script is essentially applying angular velocity. It takes a random value and it applies it to the inside sphere, and there's a tumble effect. And that tumble value is something we can set to change the rate at which it tumbles. And that sets the rigid body angular velocity, and the Unity physics engine will show this object rotating. Okay. So, and like I said, the small asteroid is the same as the large asteroid. The only difference is it's the scale. So, let's look at the player component. Let's see. We'll try to get the player component here. All right. So here's the player component. Let's see if we can get this in a little better view for you. All right. This indicates that there is sound, and I've tried to eliminate it, but it's always in the way. So let's try to position it so that it doesn't really affect the view very much. Okay, there you go. All right. So now this is the player ship, the object. You'll notice that it has two distinct game objects associated with it: the laser bolt and the thrust from the engine. You'll notice that and those are things that are children of the player object. So if we go to the shot spawn, you'll see that here's the position of the shot spawn. We put that in front of the ship because you want the laser bolt to look like it came out of the ship. It came out of the front of the ship where there was a weapon, not it all of a sudden it's in the ship and then it appears outside. So we move its position in front of the ship, and that's determined by this thing called shot spawn. The engine components has a jet core and a flare, which is this effect that you see here. Okay, now let's look at some of the scripts that are associated with it. You'll see that this uses the ship uses a mesh collider, which is here, instead of a capsule collider. The difference is that if we had used the capsule collider, then if an asteroid had hit here, it would have blown up the ship, even though it never really touched the ship. So we want to use a mesh collider so that it follows the contour of the ship. And that's why we use the mesh collider. There's a rigid body because we have physics that has to deal with this. It's a ship, it has a physical mass, and we have to control all sorts of aspects of movement, angular drag, and so forth. The mesh renderer is the skin that you see. In this case, it's the player ship metal. That's what you're looking at there. All right, so this has one script, and it's called the player control script. And you'll notice there are values in the boundary, X-min, X-max, and so forth. There's the shot, the actual shot. You'll see that it's bolt, shot spawn. That's this component here. And the fire rate and player explosion. So these are all values that are public values that we set. So let's go to the player controller. All right, so as you can see, the player controller starts out with, it has these boundary conditions, and that's how it knows to stay in the game play area. You have the information about the laser bolt, the explosion, which is all public, and here are all the private pieces of information. All right, so you'll notice here there's this init fire laser and previous fire laser variable, and a fire rate. So we'll talk about that shortly. Here's your startup code, and the startup code is initializing the variables to 0, and then it sets a player preference. The player preferences again are global values, so that when you move between one scene and another, you lose the variables and information that you've stored. The player preferences is global to the client. So if you need to save information between scenes, that's a good place to put it. If you need to save information so that when the player runs the game the next time, he has his old score or old values, this is also where you put it, because one of the methods for the player perfs is save. And then we start this laser bolt fire thread routine. Now, the update method will update this frame. We'll update it once. This execute will be executed once per frame. So you'll notice that there's a section of the code to see if we're disconnected or not. And the important thing is that this code here is really only used for when we're single player mode. That's why we're checking to see if we're disconnected. So you'll see that we get the game button information, and then we set this flag, the previous fire flag you saw. We call this method that sets this to 1. And if the game button hasn't been pressed, then it does this code, which checks to see if previous is set to 1, and if it is, it resets it to 0, and so forth. This previous and fire is happening because I don't want this code, fire laser 0, to be executed every single frame. So once the button is pressed, I'll enable this to true, and what that does is that that will, when it goes to the else, when the button isn't pressed, it'll prevent this from firing the laser. Okay? So that's what that's there for. Now, the issue with the laser. The code that you saw here, start coroutine, is a thread firing for the laser bolts. Now, the reason why that's working in that way is, let's get to the laser component. Okay, here we go. Here's the fire laser bolts thread. You'll notice that there's a while loop, and it's looking at that player perfs terminate. This is a way of stopping the loop and letting it fall through so that the thread goes away. But you'll also see that I'm checking to see if get fire laser is equal to 1, and if it is, then I'll do another check that says is laser set to 1, and then I'll instantiate the bolt at the shot spawn position. I'll play the audio, and then I'll pause for the fire rate. So this determines how many bolts you can send when you hold down a button or when you press. Now, the reason why I did it this way is that when I originally did it, every time a button would be pressed, I'd instantiate the laser bolt, and it would be on its way. Now, that worked fine when it was in single player mode. I'd hold the button down, and you'd see, repeatedly 10, 20, 30 bolts firing in a successive order, separated by a certain amount. When I added the multiplayer mode and I pressed the button on my screen, I noticed that the other screens that the players see is I might have 10 laser bolts firing. I only see 3, maybe 4, maybe 5, and they're spread out. This is because the remote procedure calls don't always work. They get missed or dropped. but there's also latency issues and so forth. So in order to make sure that it was the same across all the clients, I had to use the concept of shutter. So the laser bolts will always repeatedly fire. And then there's a shutter. And essentially what we're doing is that we're saying open the shutter or close the shutter. That's why it's 0 or 1. So when we open the shutter, the laser bolts are repeatedly created. And when we close the shutter, the laser bolts are not created. So this has the effect on all the other clients as rapid fire. And I see the same effect that I see. All the other clients see the same effect. So this is an approach that I use to solve that problem. Now, there were some idiosyncrasies with the buttons. If you press the button, what happened was that the system was getting confused between a fire button being pressed and the button being pressed that says move left, move right, move up, move down. So what would happen is that when I press the button for move left or move right, it would also fire the laser button because there was no way to distinguish the two of them. So what I had to do is I had to add a second shutter. And so when the laser fires, both shutters are open. When I press the move left, move right, move up, or move down button, it closes the second shutter and keeps it closed. So that way the laser doesn't fire. And when the fire button is pressed, both shutters are opened up, regardless whether the second shutter is shut or not, is closed or not, they're both open. So that's how I solved that particular problem. All right, so, okay, so we talked about the update. This on-photo serialized view we'll talk about when we get to multiplayer mode. You have this fixed update. The fixed update occurs before the update on each frame. And in there is how we're moving the ship. So I have to do things differently in multiplayer mode than I do in single player mode. So when I'm in single player mode, I just go and move the ship. When I'm in multiplayer mode, I have to make sure that how I'm moving the ship is important because I have to send a piece of information to all the other clients saying that I'm moving the ship. So the ship has to move on their screens. And I will also get that same message because it doesn't distinguish between who sent the message. So that's what this is mine is. It's a photon view check method. And it tells you, is this your friend? Is this your client? Is this you, or is it information that came from everyone else? And if it is me, then I want to move the ship. If it's not me, I don't want to move the ship. All right? And I want to move the ship. If it's me, I want to move the ship this way. If it's not me, I want to move the ship. Taking into account correction, player position correction, latency time, and so forth. Because when the ship moves on the other screens, they'll be kind of jittery. And this is a way of smoothing the movement. So I have to know what to do between them. You'll also notice here we have our on trigger enter. So it's the same idea. You have a ship. The ship is stationary and an asteroid comes into it. It will destroy both of them. And it's the code within the ship that's being played. It's executed, not the asteroid. Now, if the ship moves into the asteroid, then it's the code in the asteroid that's executed. But since both are moving at each other, both events will happen. So you'll also see that here's the concept of the boundary again in the enemy, because once the ship appears into the place, it's dropped into the play area, you don't want it to destroy itself because it says that the boundary has just ended its field of view in the collider. Okay? And when a ship is destroyed, the game is over. And that's what this is doing here. All right, so we talked about those methods. Like I said, here's the shutter, fire laser. It's essentially setting a variable. It opens up a shutter. I can check the value of the shutter. And when we talk about movement of the ship, here we go, the movement of the ship. You'll see that we're taking information from the input axis for horizontal and vertical, and that's this control is called. And we get the information, we round it up, and we determine whether it's a vertical movement or a horizontal movement coming from the game controller. And once we determine that, we add some physics to it. We change the rotation and the position of the game object, and then we set the values of the rigid body. The rotation is for banking. If you notice that when the ship moved to the right, it would bank to the right. The ship moved to the left, it would bank to the left. And that's what we're doing with the rotation. The position is where the ship is. Is it up? Is it down? Is it left? Is it right? Which way is it moving? Like I said, the rotation, you'll see there's a tilt. Okay? And that takes care of the player. So we've touched on the major components of game, and now you've seen it and ready to move on to the multiplayer aspect. So let's get started.